Welcome to today's lecture. In this lecture, we will continue the study of coefficient of elasticity. In the previous lecture, we had seen how to measure the responsiveness of change in demand with respect to change in price, and we came to the definition of coefficient of elasticity. And for a linear price and demand function, we saw that this constant is always negative, and between the values between less than minus 1 for the negative numbers, if the coefficient is elasticity is negative number less than minus 1, then is very responsive. So, it is very elastic in the sense that a small change reflects in a big change in the price and demand. A small change in the price will result in a significant change in the demand. When it is equal to 1, this coefficient of elasticity is 1, there is equal change. So, this is why it is called the unit elasticity, that price. And less than between minus 1 and 0, there is not much significant change that is going to come if we change the price. Not much change comes in the demand for that coefficient of elasticity. So, all that depends upon the model. How is the model, what is the slope of that linear model, but it does not depend on the units being used. So, that is so. Let us look at some more examples for this. Let us look at the demand and price and demand function given by P is equal to 2400 minus 0.5 Q. Okay. So, for this linear demand function, minus 0.5 is the slope of minus 0.5 is the slope of this linear demand function. So, at a price 1800, when the price is 1800, we can calculate what is the change, what is the Q. So, when it is 1800, we can calculate what is Q, and from this equation we calculate Q to be 1200. That means, when the price is 1800, the quantity demanded is 1200 units. So, the elasticity at the point P equal to 1800. So, this is indicated elasticity of demand at 1800 is minus 1 over B. So, here B is 0.5. So, minus 1 over B multiplied with the price P by Q. So, 1800 divided by 1200, that is minus 3. So, the coefficient of elasticity for this function at the price 1800 is minus 3. So, let us see how does this affect the scenario. So, demand is elastic at 1800, it is less than minus 1. So, at the price 1800, if there is a change, okay, say if there is a 1% increase or decrease in the price, then what is the change in the demand? So, then Q, there will be a minus 3% increase, because coefficient of elasticity is minus 3. So, if there is a 1% increase, then there will be a 1% decrease or increase in demand. So, if there is an increase in the price, there will be a decrease in the demand, 3% of that. So, let us compare it with the exact change that happens in that scenario. So, just to see how much the coefficient of elasticity is a good measure of responsiveness. At the price P1, which is 1800, Q1 is 1200, and the 1% increase in the price gives you the price as 1800 plus 18. So, the new price, okay, that is an increase. So, the new price will be 1818. Okay, right. So, now let us look at what is the, for this new price P2, what is the demand Q2. So, we can calculate that. So, Q2 from that linear relation, we can compute Q2, and that is equal to this. So, what is the percentage change? So, we are calculating the actual thing. So, the percentage change Q2 minus Q1 divided by Q1 multiplied by 100, that is the percentage in Q2 minus Q1, that is equal to, this simplifies to be equal to minus 3. Okay. For P equal to 100, okay, the Q corresponding Q change will come out to be 14, right. From the same formula, from the demand, price demand, we can calculate Q. So, actually what is happening in epsilon d at 100, price comes out to be equal to right 1 minus 1 over b, p by q. So, that is equal to minus 0.04. So, that says, thus even if there is a decrease in price, it will not boost the demand significantly, right, or vis-a-vis. So, because the coefficient of elasticity at 800 is just 0.04, very low, which is very near 0. Okay. So, this is how we analyze the effect of change in price and change in demand in terms of coefficient of elasticity. Now, next let us look at interpreting coefficient of elasticity in terms of purely in terms of demand or in terms of the price. So, we know that the demand price demand function is P is equal to A minus B Q, where B is a positive quantity. So, by the formula epsilon d was equal to minus 1 over B P by Q, and what we do here is we put the value of Q in terms of P. So, Q is equal to P minus A divided by minus B. So, we put that value here. So, that B minus B cancels it, it is equal to P divided by P minus A. A is that constant in the linear equation, that is the intercept, y intercept. So, coefficient of elasticity for demand epsilon d can also be interpreted in terms of the price, right. So, that is P divided by P minus A. So, here you see that the slope is not entering into the picture at all. So, this is a formula for coefficient of elasticity of demand at a price P. So, what are the consequences of this formula? For example, we said that if epsilon d is equal to minus 1, okay, there is a number between minus infinity and it is a negative number. So, if it is equal to minus 1, this will happen if and only if this is equal to minus 1, right. And when we solve that equation, that says P is equal to A by 2. Okay. If P is equal to A by 2, then coefficient of elasticity is equal to minus 1. That means there is a unit elasticity at that point. Next possibility, when epsilon d, the coefficient of elasticity is between minus infinity and minus 1. It is less than minus 1, and we saw it is very responsive, and this in terms of the price is related with, if we put the value P divided by P minus A is minus 1. So, that means P is less than A2. So, when the price is less than the number A by 2, the price and demand are related with each other, and the coefficient of elasticity is very responsive. A small change in price will result in a much bigger change in the quantity demanded. And finally, when it is between minus 1 and 0, so that gives the relation P is bigger than A by 2. So, coefficient of elasticity, the values when it is highly responsible in terms of the price, when P is equal to A by 2, it is unit elastic. When the price P is less than A by 2, that is very responsive, highly elastic, and this P is bigger than A by 2, it is non-elastic. So, this remember coefficient of this A is the constant which appears in the linear equation P is equal to A minus B by B times P. So, right. So, that is geometrically that was the intercept also. So, we can represent it geometrically as follows. So, if this is the price demand function, okay, here is the price. Okay. So, as you see, as the price increases, demand is decreasing. So, that is the price demand function. It says unit elasticity occurs when the price is A by 2. When the price is bigger than A by 2, it is very elastic. Here it should be minus 1. Okay. So, that is a, so this is a typo here, that should be minus 1. And when the price is between A by 2 and 0, of course, price is never going to go 0, it is highly inelastic. So, that is the portion. So, that is the relation between elasticity and the price in terms of the coefficient A. And the earlier definition, in the definition we had used the constant B, that is the slope. So, both formulas are useful in interpreting results. This is till now we have defined coefficient of elasticity of demand at a particular price P. We can also look at coefficient of elasticity of demand in a price range in an interval from P1 to P2. So, to do that, what we do is the following: to measure the elasticity of demand over a price interval P1 P2, right, which is denoted by coefficient of demand, coefficient of elasticity of demand in the interval P1 to P2 is defined as, this is a change delta Q by delta P. That also is nothing but the relative change, proportionate change in Q by P, and here it is the average. Instead of taking P by Q, we take the average P1 plus P2 by 2 and Q1 plus Q2 by 2. We take the average of that interval. So, we get minus 1 by B, P1 plus P2 divided by Q1 plus Q2. So, normally coefficient of elasticity of demand in the interval P1 to P2 is also called arc elasticity of demand over the interval P1 to P2. So, that is also the name given to this number. One can also interpret, see, we have looked at in terms of price and demand. We can also look at a equation where price and supply relationship comes. Normally, a price and quantity supplied is given by say a linear relation of the type, normally it is P is equal to A plus dQs. Qs is indicating this is the quantity supplied. Okay. D is a constant which is bigger than 0 and A is bigger than 0. This is a linear equation. What does that mean? That means if D is positive, as Q increases, okay, as the supply increases, okay, quantity is supplied. Okay. So, this is the relation between the slope here, D is positive. So, as the supply increases, the price will drop. So, here the coefficient of elasticity of supply is 1 over D, this is D, because we have to put in terms of minus. So, that is minus minus, so that cancels. So, it is 1 over D P by Qs. Price elasticity of supply for the linear equation. One can interpret it accordingly in situations. Let us look at some more facts about linear functions which are going to be useful. First of all, this slope which is m, right, if it is positive, that means the graph is rising. So, that means what? As you move from left to right, as you move from left to right, it will increase, y increases. So, if this is y, this is x, x is horizontal, y is vertical. So, the graph will look like this way, right. From the left to right, it is increasing, it is rising up. That is why it is geometrically it is rising up. Mathematically, one will write it as for x 1 bigger than x 2, f of x 1 is bigger than f of x 2. So, that is called increasing or strictly increasing. Such a function normally is called a strictly increasing function. So, if the slope is positive, the linear function is strictly increasing. And how much it can increase? A linear function will increase to any value you like. So, one writes it as limit x going to infinity. As x increases, f x keeps on increasing. As x becomes very large, f x also becomes very, very large. So, that is interpreted as saying limit x going to 0 of f x is equal to plus infinity. Similarly, if m is negative, then the graph is dropping downwards. Then as you move from left to right, the horizontal, that line, that is a graph, should be coming down. So, it should be sloping down, dropping downwards. So, that is in mathematics terms, we say the function is strictly decreasing. For x 1 bigger than x 2, f of x 1 is strictly less than f of x 2. So, x 2 is smaller, but f of x 2 is bigger than f of x 1. So, that is called a strictly decreasing function. And how far it can decrease? It can decrease to the value minus infinity. It can become as small as you want it. So, these are some properties of, but keep in mind this is only a symbolic way of saying limit x going to infinity f x is equal to plus infinity is only a symbolic way of saying that the function keeps on increasing to any large value you want. And similarly, limit f x x going to minus infinity is saying that the function should decrease, right, is decreasing and can become as small as you want it. Let us look at some non-linear models. Till now we have looked at a very simple models of price and demand. There are some other equations which appear in study of economics, commerce and management. So, let us look at an example. Let us look at the price of a commodity, which is price per unit is 3.50. Then the total revenue of the firm selling this product is a function of the units sold. So, P units are sold and each unit is sold at a price 3.50. So, we get the total revenue. Okay. This is the price per unit if Q units are sold and P is the price of per unit that is given. Okay. So, total revenue will be P times Q. So, price per unit is equal to 3.50. So, total revenue is 3.5 Q, where Q is the number of units sold, that is the total revenue of that particular company. So, this is a linear function, obviously it is a line, it is graph of this is a line passing through the origin. So, here what we are assuming is that the price is not changing now and then, right. P is fixed, the price is fixed. So, this is what normally is called a perfectly competitive policy for the company. Supposing this policy is changed, okay, and suppose the firm decides to link the unit price to the demand function by this relation, by a linear relation. So, P is equal to minus 2Q plus 50. So, the price is not fixed. It says depending on the demand our price will change. So, this is a variation in the price and but this is a linear equation. So, here the price decreases as the demand increases, right. If Q increases, P is decreasing, demand decreases. So, this is perfectly okay, that depends on the company what price relationship they want. So, this is called a monopolist policy, right, in which the price is linked with the demand. In this case, let us calculate what is the total revenue of the company. Again, total revenue is P into Q, the price into the quantity being sold. So, P here is this function. So, this gives you minus 2Q plus 50 multiplied by Q. So, that is minus 2 q square plus 50 q, and this total revenue is a function of q, but it is no longer a linear function. The power 2 is appearing here. So, this is no longer linear. So, study of these functions is called the study of quadratic functions. So, we define a new type of functions now, a function f x given by the formula f x is equal to a x square plus b x plus c for x belonging to a subset of real line, where a at least should not be equal to 0, because if a is equal to 0, this just becomes a linear function, is called a quadratic function. So, a quadratic function f x is equal to a x square plus b x plus c has got three constants, a which is a coefficient of the power 2 x square, b x where b is the coefficient of the power 1, and c is with the constant term. So, one says c is the constant term, b is the coefficient of power 1, and a is the coefficient of power 2. So, this is called a quadratic function, and of course, we are putting the condition that a is not equal to 0. So, let us see what is the use of this kind of equations or such kind of functions. Suppose the profit function of a company, as we saw in the previous example, is given by a quadratic function. Okay. So, the profit function is called, this is a symbol called pi, pi of q, right. This is a capital pi, the Greek letter. Instead of writing p, p may look like the price. So, one uses the symbol pi, pi q, the profit function is a function of q, the number of units being sold, is a quadratic function a q square plus b q plus c. So, where q is the number of units being sold. So, if we want to say this is a profit, okay, if the profit is positive, the company is making a profit when pi q is positive. When pi q is negative, the company is going in a loss. So, what is pi q equal to 0? That is the values q where pi q is equal to 0 is the are the values where company will break even, where it is neither making profit nor making any loss. So, such values, such q, the number of units being sold, is called a break even point for the company, the break even values. So, for a to find out the break even points for a company whose profit function is given as a quadratic function, one has to solve a quadratic equation. So, this is important. So, it becomes important to know given what are the values of x when a quadratic equation a x square plus b x plus c will be equal to 0. So, here a, b and c are constants, and the value x for which this is satisfied is called a root of the quadratic equation. So, our next aim is going to be given a quadratic equation, that means given if we know the coefficients a, b and c, what are the values of x for which this equation will be satisfied. So, to solve this, let us proceed as follows. Since a is a quadratic equation, a is not equal to 0, so we can divide by a. So, let us divide by a and we get the equation, namely x square plus b by a x plus c by a equal to 0. Okay. So, what we are trying to do is we are trying to form a complete square by using a method in mathematics called completing a square. So, this is x square. So, what this term we multiply and divide by 2. So, this can be written as 2 multiplied by b by a into 2, that 2 in the denominator is a commodity here. So, it is 2 times this term in the bracket x. Let us add square of this term b by 2a, okay, both on the left side and right side. So, when you add it on this side, this becomes this equation on the left side. On the right hand side, you have added b by 2a to the power 2, and c by a we have taken it on the other side. So, that is minus c by a. So, we get x square plus 2 b by 2 a x plus b by 2 a square is equal to this constant on the right hand side. So, this reminds one of a formula in school algebra, namely x square plus 2 something into x plus something square equal to something. So, left hand side is a perfect square, it is square of x plus b by 2 a. So, using algebra formula, one writes the left hand side as x plus b by 2 a whole square is equal to b square minus 4 a c divided by 4 a square. So, once this is okay, now we got a square, we want to find the value of x. So, we take square root on both sides. So, this implies, namely, if this quantity is bigger than or equal to 0, we can take square root on both sides, because for negative quantities, negative real numbers, square root does not make sense. So, that gives you that this is x by plus b by 2 a, this is the square root. This side we will be either plus or minus square root of this quantity, and square root of this quantity is square root of b square minus 4 a c divided by 2 a. 4 a square is 2 a, plus minus we have already accommodated here. So, that gives you the value x is equal to minus b by 2 a. This term can be taken on the other side. So, minus b by 2 a plus minus b square minus 4 a c. So, this gives you two values of x, x is equal to minus b plus minus b square minus 4 a c divided by 2 a. So, we get two possible values of the quadratic. So, if the quadratic is a x square plus b x plus c equal to 0 and b square minus 4 a c is not equal, this number is not equal to 0, then there are two roots possible, x is equal to minus b plus minus b square minus 4 a c divided by 2. This quantity normally is called the discriminant of the quadratic, because it becomes important to know whether the quadratic will have solutions or not. So, what we have done is we have tried to solve a quadratic and find its roots. So, the roots, two roots exist, the roots are two roots exist if b square minus 4 a c is bigger than 0. So, we will continue this study of quadratic equations in our next lecture. Thank you.